formula that right near the middle should say parallel in that series. We are going to, now we already have a lab to start. It is self-explanatory for the most part. I'm going to be holding your hand, you know, whenever, anytime it's necessary. And who does not have their lab book yet? I made a few extra copies. Yeah, I'm going to have to make more copies. I made like 6. Usually it's how many I need. So let me see how many we need one right now, and I'll make 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, so I'll make more.
One more for this.
Okay. I'll make a bunch. Usually half the class or so don't have a lab. Let's see what it says. We're going to be learning about the multimeter, and I'll put pictures on the board and explain. So I won't be. Normally, I don't do a lot of lecture in lab. I'm always happy to answer questions and explain what's going on. But this one's going to require, obviously, since we're all new to this, it's going to require some more involved explanation. There's my original evidence fixed. At any time, you know, if you have questions about the military or airlines or anything aviation related, or why, you know, even as a passenger, why something happens when you're flying as a commercial, I generally will have an answer for you. And I've got a couple other resources up here too. I've changed a lot of windows, passenger windows, along the side of the airplane. Those little windows, and I'll just give, this is just a nice note to keep you awake, and it's fun to know, but those little windows, they're just little spring clips that hold them in. The window is bigger than the hole, so the airplane's pressurization is what snugs it in nice and tight. We had a commercial airliner where the firemen wanted to know if they could just practice on the airplane and hose it down. Well, they ran their hose across those windows, and they punched in about 60 windows. It took us all night to get it back in, plus the water that entered the airplane. I have a picture of one of those side windows with a crack in it.
Oh my God.
This is the type of stuff you'll run into at 3 in the morning.
Hey, you know, you got trouble.
Oh, yeah. Let's take your kid to work day.
It's a good way to get rid of the baby.
Okay, so what there's really not much I can do right now. I'm gonna go make some copies of the Lab 1 exercise. You know, we have tonight and tomorrow, and I think I wrote as Friday as far as completing it. So we have plenty of time. I don't like to rush on the labs initially. The labs, hopefully most all the information that you need will be covered in the lecture before the lab. That's the way it's planned. And I kind of let you muscle through it. I usually just sit up here and just watch in amusement. But and I'm happy to answer questions. But I find that you learn a lot more if you sit there and read it a few times and think about it, rather than me tell you what to do every time. And when you guys work together too. So let me go make these copies. I'll make like 12 of them. It should be enough. We are supposed to be here 10 to 11 tonight. Since it is our first night, and I know this is going to take a little adjustment, I'm going to go a little easy on you. Probably let us out of here around 10 for the first night. Doesn't hurt to ask. Sometimes I'll laugh at your questions. If you're an aircraft mechanic, you've got to have thick skin. I can tell you lots of stories about things that mechanics have to go through. In the commercial airlines, the pilots don't typically get along with maintenance and vice versa.
Oh, come on.
I'm not going to badmouth the pilots. You know where the airline made the mistake is they're in different unions. I think that's the biggest problem, because they don't have each other's best interest, and one union's trying to achieve something and the other one has no interest, and then vice versa happens, and the maintenance and the air crew end up butting heads. So hang tight. I guess I'll give you what copies I have. I've got like 6 of them up here. I'm just gonna leave them up here, and whoever wants, and then here we go. We've got about 6 copies of these. So you can get them, share them, look them over. It's gonna require me to get some stuff out, I think, of a locker possibly. But I'm also gonna do a little bit of lecture, so I'll go through it step by step. So you start to familiarize yourself with the labs look like and what they're asking. Give me a few minutes.
Where's the information for this? Chapter 10, reading assignment chapter 10.
Wow.
My boss is, I'm just gonna get it through. It's all just
Man, he said he would like to. Isn't this the one that made him lose his life? This is the class that made him cry. Yeah, it's not. Did you see the lab pack?
Yeah, I did it on my way. And I know it was all. I would have bought the book. No, dude, honestly, that book's still really good to have around. Oh, no, for sure. You can make a lot of side notes in that book where you can't really get it. Alright, man, let me look at it. Analog, so that's it. Analog and digital multimedia. Rail sensors, sonar, all about that shit. Tractor, static electricity.
So those are printed. They're gonna take a few minutes because they print both sides and they staple.
PSD configuration.
So we just completed, we have a little flash drive.
Yeah, for any of my presentations,
You recommend it?
that would be the best. If you really want them, I'm more than happy to share them. But like I said, it's all in your book. If you have the book,
Is it general 1 and general 2 book?
yeah, can I see you? Yeah, if you hold this one up, this is the book, and you can print this for free off the FAA website too. But what you could would probably be very beneficial and more time, probably helpful time-wise, would be as I'm covering the material, do you highlight and make notes in the book as we go?
Probably
But
less.
again, either way, whatever works. I had one more thing I was going to show you, the Air Force recruiting ad. I'll try to show you some new computers, nothing's loaded. I'm going to try to share some humor with you occasionally.
Now the mute's on the bottom.
Thank you.
What is this?
America's Air Force.
A lot of people are like, aren't you too young to be a pilot? And, you know, hey, don't worry about it. You know, I just look young. I mean, you don't know how old I am. I'm BI-5 Predator. I just dropped a bomb. You just let me drop a bomb. No big deal. I mean, you know, if I can do it, you can do it.
U.S. Air Force.
That's what it is.
Okay, let me get those other copies and then I'll start.
That's hilarious. Let's drop the bomb. I can do it. You can do it.
My keys and my thumb drive are on the same for good reason. I don't intend to leave, put it down.
Alright, so where is this in this book?
It says 1070.
270. Ah, you're taking being poor, taking forever. It's like a really bad porn. Oh shit! Oh, I wonder. Check up like
You should just type it in on the top right there.
oh, there you go.
10-7.
70? Yeah. That don't work. Alright, so what are we looking at?
Starting with this one.
Should pretend panel. Like, what is panel? Fucking know any of that stuff.
Didn't finish printing because it ran out of paper, but it's continuing now. There still needs one. One more copy. Happy with that one? Yes, that's the same one. No reason I'm printing, I'll print this first one, but the bookstore sells this for $4, the whole packet.
We got an extra here.
Okay. Okay, we don't do it. Okay, if you look, it tells you what you're going to learn today. We're going to read the linear scales on an analog meter. If linear is equal, so sometimes it's going to ask you in a test or refer to a nonlinear scale or a linear scale. The nonlinear is going to be where it may be 10 unit increments, but it'll be 10 units, 10 units, 10 units. As it gets near one end, that 10 unit increment gets to be really close. That's a nonlinear scale. A linear scale would be 10 units is exact same width all the way across. And then use the range switch to select the appropriate meter range. So these meters will read various voltages. And for accuracy and also the function of the meter, we want to dial it in as close to what we are actually measuring. So we're going to describe and learn about that. Read a nonlinear scale and identify and use the functions of a digital meter. There is a reading assignment if it's, you may or may not need to do that tonight. Okay, so I need to get you each don't know if I don't have enough meters, so you're gonna have to share, but I'll bring them all out. I need both meters and their owner's manuals, hopefully I have all their owner's manuals.
This is cooperative graduate. Yeah, I like to look at the dark, some wall meter.
Never heard of that. Very interesting. I'm gonna just start bringing them in, and you guys can divide them up among your tables. There should be an owner's manual with each one.
Oh, okay, so what's
So cool, man. You got the old
Okay, these are all the ones I have of the digital. I'm sorry, of the analog. So we will share them, and I'll also put some images up on the screen. I can even read that. I can even read that. That's a classic. I have digitals. You don't have to get the digital now, but when we come to it, or it doesn't matter. I'm going to talk about the first meter first.
These are ancient.
Yeah.
What is full scale deflection?
What's that?
I don't even know what half these terms are. Full scale deflection.
What was the one that you wanna put in on the right? When you use the battery, yeah, if you measure the wrong thing, you blow it. You blow it back. Yeah, there's somebody, yeah, you can take a. You have to know what you're doing. You can screw it up. You can sandwich. Yeah, 2 minutes after, and you select a lower scale. Oh, because the amp has the ohm or the resistor in there. If you choose the wrong one, it can blow up and blow the fuse. I think that's what
And then
happened.
you put in your fuse, but it doesn't destroy the fuse.
I know. Alright. I'm just throwing that out there.
Yeah, no, you gotta,
I'm building everything.
It'll pay.
It'll peg. I think, yeah, that's how they do have fuses. Yeah.
Okay, we'll go over that here in just a second.
It's got music too. I think that one. That's like, that's what you want.
You're gonna throw some attitude.
I got one of those.
Because, yeah.
Yeah. I don't know what I'm doing.
So we got the mass. We actually didn't find
We did find an owner's manual for some.
Put it back in the box, so we gotta read in. understand
Okay.
that for using.
Oh, wow.
There we go.
Wow, you got it all.
I got it all now.
Let's see. I think I've got. There it is. Okay, I've got some information on my laptop for
Electronic.
With
With damage on the line.
Ooh.
Is that a 260?
It's a 260.
I have images on my laptop, but it'd be faster to just Google it.
Rather pricey.
Yeah, these are not cheap units. This is an old meter. I think they still make them. No, I do know they still make them. But this is a good industry standard, solid meter, and it's been used for decades. They still make them. So the meter, the large black one, it's you can read volts, amps, and resistance with it. So it's going to allow you to take measurements. So this is handy in troubleshooting and understanding how things work. You can check switches to see how they work or if they work, light bulbs, batteries, and toys. Like I said, I've got a digital meter like this yellow one in my kitchen drawer, and I use it almost daily. If something, anytime before I throw a battery away, I check it one last time. I've saved myself from throwing away a lot of good batteries. So, tell me if this one should look like yours.
Exactly.
In that case, you throw the remote away.
Well, come close. I've almost thrown a couple of good things away. If you guys have any small device that doesn't work, I've had people bring things in, and I've got a camera up here. We can put it right under the camera, and we can do some tests. And we fixed a few things for students, and we all sit and watch it. And I use the meter, and I show you how I use the meter to just kind of get started and figure out, start doing a little process of elimination. So normally, this common down in the corner, you've got a black and red wire.
Yep.
And that black one's always going to be here. And then all the other holes, you've got 1, 2, 3, 4, 5, 6, 7 other options where the red one can go. In most cases, your red and black are going to be down in this corner. The positive is red. When you get these meters, and I'm going to tell you several times because it's going to happen no matter what. But in these R positions, when this knob is in the R position, you are using battery power from the battery that's inside the meter. So when you put this meter away, you need to make sure that it's any position other than these with the R. And the R is for resistance. I have milliamps, which is a percentage of an ampere. I have resistance times 1 times 100 times 10,000. We're gonna learn all of these over time. I have 500 milliamps, and I have voltage. I have an AC option, and I know some people can tell me what AC stands for. Alternating current, and then direct current. So AC is what we have in our house typically, and DC is what we have in batteries. Aircraft, large aircraft have both. Probably most aircraft have, I'm sure the smaller aircraft probably just have DC like your automobile. So if I'm gonna make measurements for AC, I'm gonna rotate the selector here, and for DC, I'm gonna put it DC positive. This meter has a DC negative, and it's not something I ever use, and I don't know where I'd absolutely need it. When you hook this meter up, this has the needle in the top. Anytime you use this to make a measurement, just do a quick tap, real quick, and watch the needle. Because the needle is going to swing one way or the other. And if it swings to the left against its stop, that's why we would tap it. We want to make sure that it deflects to the right. If it deflects the wrong direction, you simply rotate your wires. And that's what they're doing with this DC positive, DC negative. If you've got the needle going the wrong direction, you can switch it. But most people who use a meter will just switch the wires.
So it's the direction the electrons are going in the DC?
This is a factor of which way the electrons are moving. Now, if you remember that we always teach positive to negative, so this meter reflects that. So we're going to assume the negative to positive concept is just kind of a nice to know. It's really going to have little or no effect on anything you ever do. So just knowing that it does is trivia. But we're going to handle everything through this class of this meter as though electrons do truly travel from positive to negative, even though they don't. So when I'm in the plus DC, the red would be on the positive of the battery, or the plus side of the power source. Now, there's a whole lot going on in here, and it seems confusing, but I think you'll get pretty comfortable with this quickly. You can see I have 2.5 volts, 10 volts, 25 volts, 50 volts, 250 volts. And then there's a 500 and 1,000. There's also a 1 volt in here. When you see these smaller numbers, that's an indication that you're going to move that positive lead somewhere else.
There you go.
So if I'm going to measure one single battery of my son's toy, how much is a typical
9 volts.
1.5 volts.
1.5 volt is your typical dry cell battery. In a flashlight and a toy, each battery is typically 1.5 volts. We do have exceptions. So I have a 2.5 volt. I have a 1 volt option and a 2.5. So I want the next higher, ideally. If I measure 1.5 volts with the setting at 1 volt, my meter is going to peg, and I don't want to do that to my meter, meaning that the needle is going to swing all the way to the right and hit the stop. So at 2 point, with my black and my positive, I can rotate this needle to the 2.5 and read the voltage. Now, I'm going to flip back and forth between a couple of images, but I've got a 500, I've got a 2.5 and a 10 and a 25 and a 50. But if you look at my display, hopefully that's high enough for you. Where I'm reading DC, right here, red is AC, and DC is black through this linear section. Ohms is on top, and we can disregard that. This 0, 2, 5, 10 is ohms. So what I'm reading is 3 rows of DC. So the top row is 0, 50, 100, 150, 200, and 250. Then I've got 0, 10, 20, 30, 40, 50, and then the lower line, 0, 2, 4, 6, 8, 10. Now, best way to go about explaining this. These last numbers are kind of are my clue as to which one I'm going to read. This 250, when I move the knob, I'm really just moving the decimal. So if I'm going to read, I'll go back to my previous picture. If I'm going to read, here's my 25. There's 25 and there's 25. That's 2.5 and that's 250. The others is 550, and then I've got a 10. So what I'm showing you is the 2.5 and the 2.5, and the 50 and the 50, and then the 10. And those are my numbers that I see here. Which one is that one? It looks like. Okay, see, there's my 10 and my 50 and my 25. So if I'm going to read a small battery of 1.5 volts, I'm going to rotate that knob to 2.5. So now instead of 250, I'm going to pretend that there's a decimal between there, right there, 2.5.
Oh.
Anytime I make a selection, if I select 10 volts on my rotary and I measure 10 volts, that needle is going to go full swing all the way to the other end. If I put it at 250 volts, or let's see, what was it, 50 volts, and I measure 50 volts, 50 volts is going to go all the way full swing. So whatever I select, if I measure what I select, that needle's going to go to its full, all the way over. So when I read 1.5 volts, I'm going to set it at 2.5 volts, and I'm going to pretend that says 2.5, even though it says 250, which means this first one becomes 0.5, 1 volt, 1.5 volts, 2 volts, and 2.5 volts. If I rotate it to 250 volts, now I'm going to measure, I'm going to read it just as it says, because that's what I have here. So if my needle is here at 200, it's 200 volts. If I'm in the 250 selection, if I'm in the 2.5, that's 2 volts. So really I'm just moving the decimal. Same with the 50. You go back, I think we only had one, I think there were two, 50 and 500.
Mhm.
Yeah, so here's 50 volts and 500 volts. So if I put it on 50 volts and I measure 50 volts, it's going to go full swing to 50. If I select 500 volts and I actually measure 500 volts, it's going to swing around to that 50. But I'm going to add a 0 to all of these. So that would be 500, 400, 300, 200, 100, 0. And then the 10, there's two options for the 10 in there. There was a 10 volt and a 1,000 volt. Trying to figure which to do in what order. So if I select 10 volts and I measure 10 volts, that needle's going to swing over to that 10. Now if you notice there's 1,000 in here, but it's a smaller number, so that's a clue that I've got to move this positive somewhere else. We're going to be doing this over a period of time, so don't sweat this tonight. If you look up, where is it? Somewhere.
Lower right.
Yeah, 1,000 volts, AC or DC. And it's reminding me to make sure that I select AC or DC. Okay, what am I measuring? I'm measuring. So if I'm going to measure, say, 750 volts or 1,000 volts, I'm going to set this to this 500 volt and 1,000 volt. If my red lead stays here, I can only measure as high as 500 volts. But if I pull it out and move it over here,
Makes sense.
now I can read up to 1,000 volts. And I'm going to read on that 10. One of those, that far scale on over here was 10 volts. Now I'm going to add 2 zeros. So if I've selected 1,000, and I measure 1,000, it's going to go full scale. And that's the closest thing I have that looks like 1,000. So that would be 1,000, that would be 800, 600, 400, 200.
Make sure.
And 100 volts would be in between. Yes.
On this one, see if you click on that picture right there, it only says 500 to 1,000.
It may,
this
this may
one-
not be the
Yeah,
exact.
this one says 250, 500, and 1,000. So would that be the same?
If you go
Would
to
this
that picture
common?
up there.
I don't know. But would this is this common always the same up to 500 on every one of them?
This one, the common is always going
I'm
to
sorry,
be the
not the
black one.
common,
The
the
positive one,
positive.
it's going to be, it may be, I can't be certain, but it's going to be the highest your maximum or whatever the highest large number is.
Oh, the red, yeah, we get the 500 on a different one. Does that answer your question?
Oh,
We gotta move the red leads to
1,000.
500.
There are slight different versions of these, but they all function relatively the same.
but with the positive, because you said the positive is up to 500 on that, right? So with ours that says 250 on it.
There is a 250. Let me see yours
This
again.
one-
Then you move your red plug over to the.
Okay, so you can read up to 250, and then to get the 500. Okay, let's do this. And I apologize for taking.
Yeah,
I
just show
am-
us. Yeah, just show us.
Perfect.
That's the best way to do it.
Okay. So the one that I showed you that I Googled had 500, but this has got a 500 and 1,000. I can't really see my holes very well with this light, but here's a 500 and 1,000, and okay, so there's my 500 and 1,000. If I'm going to read up to but less than 500, I'll keep the black one in the common, and I'll move the positive to the 500. I have an AC or DC, so that's my reminder to make sure that my selector is set for AC or DC.
If you try to measure something that's 50 and you only have it on the setting of 10, does that actually damage the multimeter in any way?
If you measure more than,
Yes.
you can. Now, normally, with an analog meter like this, I always recommend that you just tap it. Just a quick tap. You're going to see two things. Either this is going to dip down, it's going to raise gently where it should, or it may come up here and slam. If it does the first or third, dips down or slams, then you'll notice that with your tap. And you're not going to do any damage. You could hold it there and drive that needle in here, and you're probably going to do little or no damage for a few seconds, but it could change the calibration, and it could possibly damage the little coil in here. And we'll talk about the internal workings. But ideally, we want to make the best effort to have an idea of what we're measuring. We all know that in our house is 120 volts. And aircraft are typically 24 volts DC or 12 volts DC. If you ever don't know what a voltage is, you automatically go to the highest. So if I knew I could put it on 1,000, and my 10 is now 1,000. If I've got 120 volts in there, it's going to be down here. That would be 200 volts. That would be 100. So it'd be just about one little dash past the longer line. And then I can make adjustments. We're going to be doing some lab stuff that's going to tell you that this is kind of the sweet spot right in here. This is where this meter is the most accurate. Down here, we're kind of lugging it a little bit. We're barely pushing it up. And as we get into the internal workings, what we have in here is I'm going to make a circle. There's a set of permanent magnets inside there. I'll just draw it like this. And one's going to be north and one's going to be south. And in the middle, we have our needle, and attached to that needle is a coil. What do we get when we put electricity through an electric coil? We get electromagnet. Okay. So what we're doing is we're putting just a tiny bit of voltage, and that's what all of these settings do. No matter what we measure and plug this into, we're taking that voltage and we're turning it down to just like a tenth of an amp, just a very small fraction of voltage to make this an electromagnet. So when we do that, it's going to want to align. This electromagnet is going to have a north and south pole of its own, and it's going to try to align. Opposites attract. So the north of this little coil is going to try to align with south, and the south with the north. So there's a spring in here that's always driving it back over here to 0. So that's where our balance is. We put a little bit of voltage to it and it starts to push against this spring in an attempt to align with these this permanent magnet. And the more power we put to it, the more it will fight against that spring and go further. So when we're way over here at this far end, we're really compressing that spring to pretty much its maximum. And when we're down here, we're really not fighting that spring much at all. So it's kind of a balance. It's still a pretty accurate machine, but if you're really trying to be the most accurate, when we're right in here, a little over halfway to about in the 5, is where that balance is the most accurate, where we're pushing against the spring, not so hard but not so light, and we tend to get a more accurate reading. And that'll be covered later. So, I'm just going to cover, I think we're just covering voltages today. I don't want to overwhelm you with this, but I think already you may have a pretty good idea of just measuring voltages. We have 2.5 and 10. We've got a single volt in there, 25 volts. So if you have a rough idea of what you're measuring, you're going to rotate the knob to that position. If it's AC or DC, you'll make that selection here. If you're using the larger number, your cables will both stay in the corner. So what are they? So let me look at. I don't want to explain this whole thing to you tonight. Okay, so procedural notes. Because it's not possible to build a multimeter that's 100% accurate, the meter reading cannot be absolutely perfect. It is, however, an excellent approximation of the actual circuit conditions. The table for data are on separate sheets. Do not write on the tables until the report has been finalized. Use a scratch pad to record initial data readings. So they're going to ask us to make readings, it looks like, but they only gave us 2 meters in an owner's manual. Consult your instructor. I'm trying to remember what. Maybe, okay, probably. There's probably it's just simulated. They've got the drawings and the measurements for you, I think. Consult your instructor about preparing the written laboratory. Okay, there's a writing section in here in a lot of these where there's lines and lines. I'm not too interested. If you want to make a note of what you experienced and what you learned or whatever, that's great. I like seeing that. But I don't need, if you don't write anything, I'm not going to lose sleep over it. I really want you to learn this material and how these things work. I don't want to grind you on every little detail. Okay, so I'm going to give you guys your meter back.
What is the VOM sample?
Volt. Yeah, voltometer, thank you. I always refer to it as a, voltometer. I always refer to it as a multimeter because it does multiple things.
Thank you. This would be something. Right here. 260 series 8 Simpson 260 series
And then the model number
what's
is
the model?
Let's see.
Series 8.
I'm trying to decide whether I need to give you any more instructions yet.
Is it a model number or just that's the series is the same?
Okay, I'm going to stick with you a little bit longer on this. Just because I know some of you have used multimeters, but some of you this still be maybe a little overwhelming. I'm going to put this back under the camera for a second.
Is the series number the same as the model number? Like it says like series HP.
They're, you know what they are is this is a 260, I think.
Yeah, that's what it
And yeah, this is a 260, and there are some. There's like 260-3, or there's 2-60-R. I think the series is what comes after this. Let me read through this and kind of walk you through it. There's procedures. I'm going to go down to procedures. Linear scales of an analog volt-ohm meter. Figure 1-2, and there's a drawing in here, shows a multi-range meter scale. To guide you through this section, the authors have followed all the steps and completed an example data table.
You're 1-12?
It is 1-12.
Sketch primary.
And that's okay. I'm just going to stick with what you're looking at, because they're not asking you off of the meter, they're going off of their drawing. So it says, what letters or symbols identify the topmost linear scale? And is this,
DC.
I'm thinking
The topmost.
Oh, the topmost.
on the meter itself, are they asking you off the meter? Yeah, see, they mentioned figure 1-12.
Yeah.
Oh, okay, hang on.
It's on the back.
Thank you.
Page 5.
There it is.
Where you at?
It's not, they will actually won't check this figure out.
That's confusing.
Yeah, this is going off the diagram. Okay, what letters or symbols identify the topmost linear scale? What letters or symbols? Okay, they're numbers. DC, I would say DC. So your topmost linear scale is the 6, 12, 18, 24. There's a scale above, but they're not linear. Or no?
Yeah, they are.
Oh yeah, no. Okay, I'm sorry. I'm thinking of a different example in here, because there's a nonlinear question too.
Okay.
Determine the range and scale. If this is a multi-range scale, record each range. Okay, so in what you're gonna fill out. You've got a 30, a 10, and a 5. Determine the range and scale. They've given you some examples, if I'm not mistaken. I haven't looked at this in a while. They filled in a lot
They
of,
filled some answers in for you already.
yeah, to try to give you a guide, to help you get started.
Well, look at this, if you look at question 1, these were the letters from almost in DC.
Yeah, exactly.
I was gonna put DC. And then this, so that there's the question.
Oh, okay.
I mean,
Go
I
back to
think.
there. There's, so
I
there.
mean, if I go with what? If we had DC, right? Core top is 30. Here's the 5. So 30. There should be a 5 somewhere. Right? So 2 is right there.
Okay.
Mm-hmm.
So what letters or symbols
6 is top.
identify the topmost
2
linear
and
scale?
1. Top 2 and 1. Okay, that makes sense.
Topmost.
Top 2 and 1 was 3.
So what goes in here?
Okay, so
Oh, so called DC.
I mean, I just.
Yeah, I think if you give us an example of how it works.
okay, when you fill this out,
5.
you're gonna fill in the same spots that they have over here on the experiment. You're gonna fill out those and these, and I remember, yeah, they look the same. Both sides. I'm just looking at the answer sheet. So it's the same. Yeah, that's right.
Oh, I see.
1, 2, 3.
So we're putting 0 to 10 here, right? Here, that. Here, 2, 0, 5, no, 0 to 10 here. I guess the top is 0.
So would this be a 4,
0 to 250
2, and then mid would be
The mid
4,
is 0 to 50.
and then this would be 12, right there.
Hear that?
Yes. Okay, so
0 to
Oh, okay, now 5 would make sense.
See, where's, so these are,
yeah, I'm gonna get
I think that's what they're asking.
Is that what they're asking for?
What letters and symbols?
I'm gonna put the answers up for you because I haven't looked at this in a while and I don't want to confuse you as trying to explain. So here are the answers for the first section. But look at this and look at your sheet and determine how they got there.
He's trying to.
okay, so you're just like giving this one. What's it
So.
50, oh, okay, because if you look at this, 50.
Are we looking at this correspondence?
I guess that's how it looks like, doesn't it?
The primary divisions are the space.
250 is the top, right?
Oh, 1, 2, 3, 4, 5.
What is
The
H?
mids
Five.
is 50.
Got it.
Just so you, okay, here's my, I'm gonna do a little simple graph. Your primary division is the space in between the lines, in between the large lines. The shorter ones, the secondary division is the space in between the shorter and maybe a long one, or a short one and another one. So that's a secondary, and this would be a primary.
Like here.
Nice.
It's the space in between, it's not the lines.
1, 2, 3, 4, 5 primary. In between, I see 10.
What's that mark there?
What I was trying to show you is the primary.
Oh.
This is a primary division is the area between the larger areas. This is the primary division. This one in here and here. The secondary division is the space in between the smaller ones.
So I got that wrong. The primary division is
Is there a term for the whole scale?
5. Full scale?
So how's the 5?
No, I don't think so.
5 and 2.
The 5 and 2?
So you can't do nothing for the 3 or 4. You don't have enough information.
Okay, so just the primary division. Why don't you go up here? Go up
Go
here.
down here. Up there, top, yeah, that's over the 5 and 2. You have one division. You don't have any other information. Within one.
This is, I think, this is the all.
I don't see the 1, 2, I see 1.
But all that was given, so you can't put anything else beside 1.
No, that's all they're asking.
And we're taking one more.
And I don't, I'd have to sit down and look at it.
Oh, right there, right there.
Yeah, and then split it down after that, right, the question.
I wanted to give you the answers, but I don't remember how they did this. I'd have to sit down in a few minutes.
All right, I'll go with that.
Yeah.
Just
But
because.
I know the bold is what they're asking for.
Prefer the unit value.
I'm hoping you'll check it and look at it to see how it relates to what they're asking.
0.
For each
Scale range. Okay, so.
Record the unit value.
So is that this one right here? So you're talking about the first.
For each of them.
So I'll let you do the sketching the divisions on your own down here on the blank line. After. But again, I'm giving you the answers to this, and I haven't looked at it in a while. I don't want to confuse you, and there's a lot going on for me to sit down and pick it through again. So I'm giving you opportunity to write the answers down and follow the questions backwards and figure out what they're asking.
Right.
Oh, 0, it's 50, 10, 2. 50, 10, 2. We got it. Yeah.
But it answers.
I don't understand.
So this is the primary, then the two are
For university, secondary.
Sketch the primary division. Oh, this is easy. This is easy to sketch by. Because what you're doing is you're going 250, doing 250, 50, 10. No, you're right. 200. Yeah. So the top one would be the top, the middle, and then the bottom. So top two. Yeah. So third. And all we do is just draw the damn thing. So basically, and then we got 0 right here, right?
Third.
So 0, 0, 0.
Yes, yeah,
We're talking about 1, 2, 3. Yeah, we are.
50, 100.
Third graduation. 1, 2, 3.
200.
That's right.
It looks something a little bit like this, right? Where you kind of.
And then the 10
Yeah, 10 underneath, and then the 2 right here, right?
yep, so 50, and then the middle value is going to be in the middle.
10 and then 2, and then it kind of goes all the way around, right?
Yeah, you got 10 at the beginning, 50, so you just divide, manage them evenly. So you got one, you get the same number, so they're all going to be beneath each other.
Okay.
Just a quick
Are
question.
they talking about right here?
Like number
Yeah,
2
so
has
exactly
top,
what we
medium,
The
and low,
second
right?
word.
Yeah. But number 5 is
Is this one right here?
high, medium, low.
One thing is 1.5.
I'm gonna have to look at it. I forget what it's asking.
2.5 and 5.
What is the, is that
Yep, so right
plus
here.
or minus 5% deflection rate?
So that's number 10. It says, what are the percentage?
I don't remember what the
Fourth
low,
scale
mid,
deflection
high
did
is.
you need? What is the percentage of accuracy?
What they're trying to
What is used
explain.
fourth deflection? And it says 90% stated, accuracy percent. So
Okay, I have another
FSD,
add
10, and then
list
divide
for
by-
this part of the lab. So I'm gonna pass this one around.
Deflection.
Put your name and number on it and take a sticker. And then when you do, when you add it, when you register or add the class, they'll ask for that sticker. Or the number on it together. I'm trying to remember what the top, mid, and low mean.
The deflection point.
Yeah, what is that?
So what is our, on our, does that say that in here? Right here, like our deflection? They probably have it right here in the book, wouldn't it? The deflection rate. I'm gonna see it.
Oh, so, okay. And do notice that it says answer using your meter. So the information you're,
Yeah. That's why it's.